All right, let's jump right in. We're going to talk about something pretty wild today. This idea that what you and I see in a picture might be completely different from what an AI sees.
So think about this for a second. What if an image could act like a secret agent? To us, it looks totally normal, but it's actually smuggling a hidden, malicious command that only an AI can understand. It's basically a visual Trojan horse.
And nope, this isn't some sci-fi movie plot. Look at these two images. To you and me, they are identical. But to some of the most advanced AI systems out there, the one on the right is hiding a secret message. This is a very real vulnerability, and we're going to break down exactly how it works. So where's this hidden backdoor? How can someone sneak a message into an image right under our noses? Well, the answer is kind of shocking in how simple it is. It's hiding in a process that pretty much every AI uses every single day. You know, that's what makes this whole thing so scary and so widespread. The weakness isn't some super complex piece of code or a crazy algorithm. Nope. It's sitting right there in a boring, routine step that's just supposed to make AI systems run a little faster. So here's what a typical AI image pipeline looks like. The AI gets a big, high-resolution image. Now, to save on computing power, it shrinks it down, it downscales it. Then it analyzes that smaller version. But see that second step, the downscaling? That is the secret door. Attackers have figured out how to arrange pixels in the big image so that when it gets shrunk down, they form a totally new message. Now, people have known about this vulnerability for a little while, but honestly, the early attempts to use it were, well, they were kind of clumsy. They were easy to spot and easy to stop. We call them static attacks. A static attack is basically a one-and-done deal. An attacker makes one corrupted image and just hopes for the best. If the AI has slightly different defenses, or if the model gets an update, boom, the attack just fails. It has no way to learn or adapt. And this lays out the difference perfectly. Static attacks, they're rigid, they're brittle. But now, a much, much smarter approach has shown up. The adaptive attack. Instead of taking one blind shot, this thing sends out a little probe, gets feedback from the AI, learns from it, and then tries again, getting smarter and smarter with every attempt. So this brand new, super intelligent approach has a name, and it is a perfect one, Chameleon. It's a whole framework that was designed specifically to master this scaling attack. The research paper describes it like that. So what does all of that fancy language actually mean? It means Chameleon doesn't just attack the AI. It basically has a conversation with it. It makes a tiny invisible change to the image, asks the AI, hey, what do you see now? And then uses that answer to make its next move even better. And here's how that clever feedback loop actually works. Chameleon adds these tiny invisible distortions to an image. It sends that image to the AI and gets back what's called a reward score based on how close it is to fooling the AI. It then uses that score to tweak its attack. And it does this over and over and over until success. The hidden command gets through. It really is like a sleeper agent, just patiently probing the defenses until it finds the perfect way in. And that right there is the key. Chameleon isn't just throwing attacks at a wall to see what sticks. It's turning the AI's own intelligence against it. It's a clever adversary that literally learns from its target. So, that's all the theory. But how does this slick attack actually hold up in the real world? Well, the researchers decided to put Chameleon up against a true heavyweight, a cutting-edge AI model. And the target was none other than Google's Gemini 1.5 Flash, a really powerful and widely used model. So the big question is, could this learning-based attack really outsmart an AI of this caliber? Oh, yes. A big, resounding yes. In their tests, Chameleon hit a peak attack success rate of 91%. Just let that sink in for a moment. 9 times out of 10, it could successfully hijack the AI's perception of an image. And when you compare that to the old methods, wow, it's not even a fair fight. While Chameleon is sitting up there at 91% success, the old static attacks could barely crack 32%. This is just a massive, massive leap in how effective these attacks can be. But here's the real kicker. It does all of this with changes that are so incredibly tiny. We're talking a visual difference of less than 0.1 on a standard scale, that they are completely 100% invisible to the human eye. It's a nearly perfect stealth attack. Okay, so this is way more than just a clever technical trick. An attack that's this effective and this stealthy,
it has some really serious consequences for the real-world systems that we're all starting to rely on. And we're talking about really critical systems here. Think about self-driving cars that are making split-second decisions based on what they see, or automated systems that are processing your loan applications, or even high-stakes financial and security systems that use visual data. All of them could be vulnerable to this. And the impact is huge. The research found that a single successful Chameleon attack could slash the decision-making accuracy of an AI system by over 45%. So it doesn't just fool the AI on one thing, it makes it fundamentally bad at its job. The researchers put it pretty bluntly in their paper. These findings are a massive wake-up call. We have to start building security checks for these big visual AI models that are specifically designed to look for this image scaling problem. Now, the good news is the security community is already on the case. One really promising defense is called a multi-scale consistency check. Basically, you just ask the AI to look at the same image at a bunch of different sizes. If a weird message suddenly pops up at one scale but not the others, that's a huge red flag. So let's just quickly recap the big takeaways here. First, a totally normal, everyday process, image scaling, is actually a massive security flaw for AI. Second, these new adaptive attacks like Chameleon are a game changer because they actually learn from the AI they're attacking. And third, this method is insanely successful, up to 91%, and it's totally invisible to us. And that means the threat to all the automated systems we're building is very, very real. Which leaves us with one last really important question to chew on. As we race ahead building this amazing future on top of artificial intelligence, how do we make absolutely sure we aren't also building in these hidden backdoors? Vulnerabilities that are invisible to us, but are sitting there in plain sight for anyone who wants to cause harm. Something to think about.